is wastewater?
Wastewater is any water that has been contaminated by human use. Wastewater is used water from any combination of domestic, industrial, commercial, or agricultural activities, surface runoff or stormwater, and any sewer inflow or sewer infiltration. Wastewater may be conveyed in a sanitary sewer that conveys only sewage. After treatment at a wastewater treatment plant, treated wastewater is discharged to a receiving water body. Wastewater that is discharged to the environment without suitable treatment can cause water pollution. One way to treat wastewater is by using membrane filtration. This is the four types of system that under membrane filtration. The fourth type is differentiate based on membrane pore size. The smallest pore size is reverse osmosis, which range in from 10 to the power of -4 to 10 power of -3 micrometers. For nanofiltration, it is from 10 to the power of -3 to 10 power of -2 micrometers. Ultrafiltration with 10 to the power of -2 to 10 power of -1 micrometers. And lastly, microfiltration with the larger pore size, which is 10 to the power of -1 to 10 power of 1 micrometers. The pressure also used in this system varies. Microfiltration below than 1 bar, ultrafiltration with 1 to 10 bar, nanofiltration with the pressure of 20 to 40 bars, and lastly, reverse osmosis with the high pressure, which is 30 to 60 bars. Microfiltration can separate bacteria and fat. Ultrafiltration can separate fat and protein. Nanofiltration can separate lactose, which is larger than protein, fat, and protein, while reverse osmosis only allows water to permeate on it. This is an example of membrane filtration. It consists of 3 layers, which is polyester base, polysulfone layer, and lastly polyamide layer. The combination of these layers makes a durable membrane flat sheet that is used in each spiral wound element. Membrane flat sheet is then combined with sheet of feed channel spacer. This provides turbulence and creates space between membranes to allow uniform flow of water to entire membrane surfaces. The leaf membrane and feed channel spacer then combine with sheet of permeate spacer, which provide the open flow channels for the permeate even in high pressure. It is glued along of the exposed side and then rolled around core tube. Clean water or permeate pass through membrane surface into the permeate channel and then flows in a spiral direction to the center of the element and collected into the core tube.
Types of contaminants that can be treated by membrane filtration. As we all know, there are 3 types of contaminants: physical, biological, and chemical. Thus, when talking about contaminants that can be treated with the use of membrane filtration, these 3 types of contaminants are also included. However, these contaminants can be treated even without the membrane filtration technique. For example, physical contaminants that can be found in wastewater are plastic bottles, branches, and also small particles such as dirt. These contaminants can be removed during the pre-treatment process. So, when talking about membrane filtration, the contaminants involved are much more smaller in sizes. For example, organics and inorganic compounds from food processing influence. Membrane filtration also consists of 4 processes: microfiltration, ultrafiltration, nanofiltration, and also reverse osmosis. In microfiltration, it separates the suspended solids in the particle size range of about 0.08 to 10 micrometer. The examples are E. coli, oil, and also macromolecules. In ultrafiltration, it can separate the macromolecular solids in the particle size range about 0.001 to 0.1 micrometer. The examples are viruses and proteins. As for nanofiltration, the membranes are multiple layer, thin film composites of polymer consisting of negatively charged chemical groups. Nanofiltration are used in retaining molecular solids such as sugar. and certain multivalent salts such as magnesium sulfate, but passing substantial amounts of most monovalent salts such as sodium chloride. Here, we have all the membrane filtration processes. When the wastewater passes through, it will pass through microfiltration first, and the contaminants that can be separated will remain behind. The same thing goes for ultrafiltration and nanofiltration processes. However, if you're using nanofiltration in your system, that does not mean that the contaminants separated are only ions and small compounds, but also includes the macromolecules and viruses.
Okay, so now I will talk about advantages and disadvantages of membrane filtration. There are three advantages that can be obtained from membrane filtration. Firstly is lower overall production cost. The system is less expensive compared to other alternative technologies. There are no costs associated with removals and disposal of this residue. Next is high flexibility. It can be used for different viscosity from high to low. Lastly is high-end product quality. This is clean technology where separation process carried out only on the molecule size. Despite the advantages that membrane filtration can provide, it also has its own disadvantages. Firstly, it retains the contaminants at a higher concentration than in the original filtwater. Membrane pooling phenomena also may occur in this system. It is a process where a solution or particle is deposited on a membrane surface or in membrane pores.
One of the major sources of environmental pollution are from wastewater generated by food industry and farming activities. Food processing wastewater include vast amounts of nutrients, organic carbon, organics and inorganic nitrogenous, and suspended and dissolved solids. It can cause high biochemical and chemical oxygen demands, which lead it to one of the most difficult and expensive wastes to handle. Due to growing demands on declining freshwater sources, extreme water scarcity, and climate changes, and the fact that water quality regulations have become tighter, it drives the food industry to implement practices of reusing water. This method is suitable to be used in food industry such as dairy industry, juices industry, and beverage industry. In the sugar industry, regeneration of waste disposal is difficult due to the increased amount of sodium chloride and colored organics contained in the regeneration effluent. The usage of nanofiltration was proved to be very effective since it can remove up to 74% of sodium chloride in the water. In dairy industry, the operation systems need huge amount of water to operate, hence they produce large amount of wastewater that pollutes the environment. The making of salty cheese whey, for example, is a major waste disposal problem. The salt content, whey solids content, and biochemical oxygen demand of the salty cheese whey are approximately between 4 to 6%, 6%, and 45,000 milligrams per liter respectively. The sodium chloride is eliminated as the permeate, which then recycled or discharged by the nanofiltration system. The desalted whey return aid is then mixed back with the regular whey, hence it can reduce the production cost. The combination of microfiltration, ultrafiltration, and reverse osmosis are also applied in wastewater treatment in dairy industry. In conclusion, wastewater treatment is important in order to ensure the sustainability of freshwater supplies in the future. Furthermore, food industry from farm to fork involves the usage of water in a very high quantity during food production. Thus, with the help of the advancement in technology, the environmental pollution from wastewater can be minimized. The usage of membrane filtration in wastewater treatment will keep on increasing in the future due to vital benefits over other technologies. It reduces the production cost, high flexibility, and produces a high-end product quality.
Therefore, the clean water can be reused for another purpose such as household use. For example, drinking water, washing dishes, washing food, and also watering plants.